Good morning, everyone. This video will continue talking about the definition of probability. In previous videos, we covered what is a theoretical probability, what is empirical probability, and the third definition for probability is a subjective probability. Let's read the definition here. The probability of event A is estimated by using knowledge of the relevant circumstances. For example, we want to know the probability that you will get stuck in the next elevator that you ride. Let's see how do we explain or solve this problem. In the absence of historical data on elevator failures, we can't use the relative frequency approach. It means the empirical probability definition doesn't apply here because we don't have the historical data on elevator failures. Well, you can understand that it's pretty not practical to collect the data for elevator failures, especially for the specific elevator that we talk about in the problem. There are two possible outcomes, becoming stuck or not becoming stuck, but they are not equally likely. If it was equally likely, then that would be horrible, right? So we can't use the classical approach, means we can't use the theoretical probability definition here either. That leaves us with a subjective estimate. So the third definition of probability, subjective estimate. In this case, experience suggests that the probability is quite small. Let's estimate it to be, say, 0.0001, equivalent to 1 chance in 10,000. That subjective estimate, based on our general knowledge, is likely to be in the general ballpark of the true probability. You can just make a well-educated guess about the chance of the event when you run out of options, as the theoretical probability definition and the empirical probability definition not options for you. Okay, that is a subjective probability. Next concept, odds. Expressions of likelihood are often given as odds, such as 50 to 1. They are widely used in gambling. In casino, you hear odds a lot. You don't really hear people in casino talking about probability, right? Then what's the difference or connection between odds and probability? They are closely related. However, they are two different things. They both describe the likelihood or chance of a certain event occurring. Let's read the following three definitions. The actual odds against, the keyword here is against, event A occurring are the ratio P of A bar over P of A, usually expressed in the form of A to B, where A and B are integers having no common factors. So simply put, what is the actual odds against event A occurring? The odds against event A occurring is the quotient of P of A bar and P of A. Well, I need to explain what is A bar. Seems like we never see it yet, right? We know we used capital letters A, B, C, those to represent events. Let's say A is an event. If we put a bar on top of A, this notation also represents an occurrence, also represents an event. And this event means A not occurring. For example, if I let A be the event that tomorrow snowing, then A bar would be tomorrow not snowing. If A represents you are getting an A in this class, then A bar would represent you are not getting an A from this class. Do you see what I'm saying here? So if we have P of A equals 20%, 0.2, then what do you think the probability or the chance for A bar occurring? In previous example, if A represents tomorrow snowing, let's say the chance of tomorrow snowing is 20%, then what's the chance of tomorrow not snowing? You would know it's 80%, right? Because altogether is 100%. That's correct. We have a very important formula regarding A bar. Again, A bar represents the event that A not occurring. The negation of A occurring. The formula is P of A and P of A bar add up to 1. Tomorrow snowing chance is 20%. Tomorrow not snowing would be 80%. They add up to 100%, which is 1. The formula we need to remember, P of A plus P of A bar equals 1. So if you know 1, then you would find the value for the other. If P of A is 20%, then P of A bar would be 100% minus 20%, which is 80%. If you know the value for P of A bar, then you know how to find the P of A, right? It's pretty straightforward. Okay, that is about A bar. The odds against A occurring simply equals the quotient of P of A bar and P of A. Second definition here, the odds in favor A occurring. Sometimes we say for, F-O-R, but in this book, the keyword here is in favor of. Same idea, same means same thing, right? In favor of or for. I am here for you. For means I'm supporting you or favor you, right? So the odds in favor of event A occurring would be defined as the ratio of P of A and P of A bar, the reciprocal of the odds against A occurring. Do you see that? This is the odds against A occurring. Against, so you kind of like favor A bar occurring. So the probability of A bar is on the top. The odds favor A occurring would have P of A on the top. For the payoff odds is a very important concept in casino or gambling field. So are we going to talk about this or not? The payoff odds. Normally I don't talk about it. So maybe I'll leave this for you. If you are interested, you can read the notes and make sense of it, or email me if you have any question. Mainly we talk about odds against and odds for. Note, in gambling, the term odds on generally means the odds against. So when you hear people talking about odds in the casino, it means odds against. It means odds against, okay? Let's see the example. If you bet $5 on the number 13 in roulette, your probability of winning is 1/38, and the payoff odds are given by the casino as 35-1. Well, let's figure out what is payoff odds. Let's take time here. The payoff odds against the A occurring are the ratio of net profit if you win to the amount bet. Payoff odds against event A is defined as the ratio net profit to amount that you bet. Then now we understand what does this mean? The payoff odds are given by the casino as 35-1. What does that mean? 35 to 1. Payoff odds. By the definition, it means the net profit to the amount that you bet is 35 to 1. Means if you bet $1 and if you win, you get $36 back. The $36 including $1 that is your bet, and the rest of the money, $35, is your net profit. Do you see what I'm saying here? Find the actual odds against the outcome of 13. So we need to find the event we are concerning here. We are concerning this, let's say this as A. How about this event means you got a 13. Okay, you got a 13. And anybody tell me what is the probability of A? Is given from the problem. If you bet $5 on the number 13 in roulette, your probability of winning is 1/38. That is given, right? P of A, P of getting 13 in the game is 1/38. Then anybody could tell me what is A bar, the probability of A bar here. Remember, the probability of A and the probability of A bar add up to 1. So if the probability of A is 1/38, then probability of A bar must be 37/38, because those two numbers must add up to 38/38, which is 1. Right? So far so good? Then by the definition, part A, find the actual odds against A. Against A would be P of A bar over P of A. You do the math, okay? You use this fraction to over this fraction. You would have 37/1 or 37 to 1. The solution is here for part A. Actual odds against getting 13 is 37 to 1. Once you understand the probability of A and A bar, and you understand the definition for odds against, then you should have no problem to find the actual odds against 13. Part B, how much net profit would you make if you win by betting on 13? The payoff odds is given, which is 35 to 1, right? So now you make a $5 bet. You make a $5 bet. Then what is your net profit if you win? They are proportional. They are proportional, you know what I'm saying? So if you bet $1 and you win, your net profit is $35. Now you bet $5, 35/1. Right now you bet $5. Then what is your net profit here? Your net profit over your bet. So you're gonna multiply 5 by 35, right? $175. Do you see what I'm saying here? Applying the proportion. The house means the casino. The house determines the payoff odds. Means if you bet $1 and you win, you got $35 net profit. So if now you bet $5, then if you win, you would have 35 times 5, which is $175 net profit, right? Net profit. And what are you looking for here? How much net profit would you make? Yeah, your net profit would be 175, obviously, right? Yeah, that's pretty straightforward and simple. Part C, if the casino was not operating for profit, how is that possible? And the payoff odds were changed to match the actual odds against the 13. How much would you win if the outcome were 13? That's an interesting problem, right? Okay, here. If the casino were not operating for profit, the payoff odds would be changed to 37 to 1. 37 to 1 is the ratio we just got from part A. That is the actual odds against getting 13, which are the actual odds against the outcome of 13. With the payoff odds of 37 to 1, there is a net profit of $37 for each $1 bet. For a $5 bet, the net profit would be 185. How did you get 185? You multiply 5 by 37. You multiply 37 by 5. You get $185. The casino makes its profit by paying only $175 instead of the $185 that would be paid with a roulette game that is fair instead of favoring the casino. Yeah, this is a pretty interesting problem actually. If you are into casino games, you might want to know those knowledge. Let's continue. Probability distribution. When we talk about probability distribution, we want to recall a similar definition we have learned from before. The similar definition that we have learned from before is called frequency distribution. Frequency distribution. Do you guys remember that? We learned a frequency distribution table. We learned a relative frequency distribution table. We also have learned a cumulative frequency distribution table. Frequency distribution table is a two-column table. The first column are classes. Remember, we have a low-letter group. The values in the group are the IQ scores of the children in the group, right? So we have class 1, we have class 2, 3, 4, 5. 1, 2, 3, 4, 5. And the second column in the frequency distribution give us the frequency for each column, for each class. Do you guys remember that? 50 to, I would say 69, 70 to 89, and so on and so on. I would recommend that maybe you go back to find the content from before. Frequency distribution table. And the probability distribution table is even better. The idea actually is the same with the frequency distribution table. For frequency distribution table, we have a sample. You know the reason we get a sample because the population is too large, not practical to deal with. So it's kind of like a frequency distribution is a certain estimation. But what if we know the population very well? We might have the probability distribution, and that distribution would describe the population even better, or more accurate, precise. Probability distribution. In order for a two-column table to be a probability distribution, 3 requirements must be satisfied. Number 1, there is a numerical random variable x, and its values are associated with corresponding probabilities. Here I am going to change this to capital letter X, okay? I feel like the book using wrong notation. When we talk about random variable, very important concept. When we talk about random variable, we use the capital letter to represent random variable. Okay, let's take time to talk about what is random variable. How about I'm talking about random variable in the next video, because this video is almost 20 minutes. I don't feel comfortable do more than 20 minutes because every time I did that, the content is, I lost the content. The video is compressed. So I'll see you soon in next video.